Here we are talking about a special type of triangle called a 30, 60, 90 triangle. The name is pretty straightforward. It has angles of 30 degrees, 60 degrees, and 90 degrees. So this is a kind of right triangle. And it's a kind of right triangle that pops up again and again. This is actually half of an equilateral triangle. So there are many applications where you find 30, 60, 90 triangles popping up. They have a particular ratio of their sides, and you can see it here. We have x. If this side is some length x, then the hypotenuse is double that shortest side. So the side that's shortest is across from the 30-degree angle. The hypotenuse is the longest. That's across from the right angle. It's double the shortest side. And then the remaining side, the one that's in between, is whatever the short side is times the square root of 3. So if you know one of these sides, if you know it's a 30, 60, 90 triangle, you can figure out all of them. Another way to think about this is with just a single unit put in for the short side. They have sides in a ratio of 1 to 2 to the square root of 3. Let's see how this works in a few problems. Here we have a 30, 60, 90 triangle. We know that because this angle 60, this angle is a right angle. That only leaves 30 left over here, so that's fine. It's a 30, 60, 90. And this one is the shortest side. So this is our one side, or our x side. And if this side is 11, we know the hypotenuse, that's this side down here because it's across from the right angle. We know that's going to be double. So this would be 22. That's just 2 times 11. And this side, the remaining side, is going to be this side times the square root of 3. So this is 11 times the square root of 3. Let's look at another here. Here we have the hypotenuse, and we want to find x and y. So we don't know the short side, which is a nice place to start out. But this shouldn't be too hard because we know the hypotenuse is always twice as big as the short side. So if this side is 14, this side has to be 7. And then, of course, this side would be 7 times the square root of 3. Here's another problem down here without a picture. It says in triangle ABC, A is a right angle, the measure of angle B is 60, and AB is 12 feet, and we want to find BC. The way to solve this is just to draw a picture, and I've got plenty of pictures up here of 30, 60, 90 triangles, so I'm just going to steal this one. Let's see, it says A is the right angle, so we'll make this A, and it says B is the 60-degree angle, so this is B, so this would be C up here. And it says we know AB is 12 feet. Aha, so that's the shortest side. So this is going to be pretty easy. We want to find BC, that's the hypotenuse. And the hypotenuse is always twice the shortest side. So this is going to be 24. So if you know the shortest side of their hypotenuse, pretty easy to figure out these problems. But what if, in a situation like this, I'm just going to draw kind of a cloud around our ideal 30, 60, 90 triangle. These are the ratios in this sort of ideal world. But what if, let's say this side is 11, and that's the square root of 3 side, and you want to find that side. What do you do now? You might be able to memorize about whether you multiply or divide by the square root of 3, but there's a foolproof way to solve for any sides if you know one of them. And that is to set up a proportion, to cross multiply and then solve, and then if you have to rationalize the denominator. Let me show you how it works here. A proportion, remember, is two fractions set equal to each other, and they show the same relationship in each fraction. The sides we're dealing with here are the square root of 3 side and the 1 side. So I'm just going to put those two together in a fraction. And the way I read this in my mind is the square root of 3 is to 1 as, and then I need to take the sides from the real world and put them in the same order. So the 11 is going to go on top because that corresponds to the square root of 3 side. And the x is going to go on the bottom because that corresponds to the 1 side. So on one side of my proportion, I've got my ideal ratios. On the other side, I've got my real world numbers. On the top, I've got the square root of 3 sides. And on the bottom, I've got the 1 sides. As long as you get your proportion set up so that it's the same like that, the relationships are the same, it'll work. So that's setting up a proportion. Then we need to cross multiply. So we get square root of 3 times x equals 1 times 11. And then to solve for x here, we're going to need to divide by the square root of 3. So we'll do that. So we get x equals 11 times, or 11 divided by the square root of 3. And having a radical sign in the denominator is a no-no. So you're not going to see this for your answer choice. We need to rationalize the denominator. And the way we do that is we just take whatever's down here in the radical sign and we multiply by that over itself. Anything over itself is the number 1. So really we're just multiplying by the number 1 here. And we'll get a different form of this fraction without a radical in the bottom. On the bottom, square root of 3 times the square root of 3 is just 3. And on the top, we have 11 times the square root of 3. So that is now an acceptable answer with the denominator rationalized. So that is a little bit of work with 30, 60, 90 triangles.